Alright guys, today we're covering 4.3, which is really just a continuation of 4.2. It'll be a really short section. We're dealing with the natural exponent function, which you've probably seen before, but we're going to kind of show you now what that number is, how we arrive there, and all that stuff. So, recall your compound interest formula, which is FV equals P times 1 plus R over N raised to the N times T. Now, what we want to recognize is what happens if we let N increase without bound. So we've kind of set up a little graph here, a little chart. As N equals 1, FV equals 2. As N gets larger and larger and larger, we went up to 10,000 here for this example, we come to the number 2.7181. What we want to recognize is as N approaches infinity, the part of our compound interest formula approaches E, where E approximately equals 2.71828, and it continues to go on and on. So that's what's interesting here. Recognize I stuffed in a couple variables here, you don't have to worry about it, but as N grows without bound, this approaches E, which we call the natural log function, which comes out to be about 2.718. We write that as your natural log function, your natural exponential function as f of x equals e to the x, where e is approximately this number. Alright, dealing with a natural exponential function is the same as dealing with any other exponential function. The rules are the same, so if I gave you something like e to the 3x plus 9 equals e to the 2x squared and told you to solve, well, the bases are the same, so we do it the same way we've done before, and that's just set your exponents equal and solve from there. Alright, and obviously you guys know how to solve this. The only thing possibly different that we're going to do in this section that we didn't do in 4.2 was find zeros. So for examples, if I ask you to find the zeros of f of x, where f of x equals 2x e to the x plus e to the x. Well, we're going to find the zeros of this just like we do any other normal equation. So we'll factor it and set it equal to 0. So we get 0 equals e to the x, 2x plus 1. Now recognize that e to the x has to always be a positive number. It's always going to be certainly greater than 0. So we can kind of ignore this for the time being and just simply solve this for 0. And you see that x equals negative 1/2 is the solution there. Alright? That's really the only difference in this section as opposed to the last section. Let me give you one more example here of finding zeros with a natural log function. And that'll pretty much be it for 4.3. As we get on further into the chapter, into 4.4, 4.5, we'll do more with the natural log function. This is basically just introducing it. Let's find the zeros. F of x equals 10x cubed e to the 8x plus 6x squared e to the 8x. I mean, you're going to solve this just like you would anything else. Set it equal to 0. We can pull out a 2x squared e to the 8x. That leaves us with a 5x plus 3. Okay. So again, we set this part equal to 0 and this part equal to 0. Well, really we can ignore this because we know that's going to be positive. So we know one of our zeros certainly has to be 0, and it looks like the other one's going to be negative 3/5. Alright? Nothing too crazy there. Recognize, you may be saying, well, this has a degree 3. Recognize this 0 is a multiplicity 2 because of the square there. But our answer stays the same nonetheless. Alright, that's pretty much 4.3. Pretty short and simple.